Are you able to see the screen? Able to see the screen?
Yes, sir.
Yes, sir.
Okay, fine. Okay, yesterday we started the new topic, ordinary differential equation. O, B, E. Ordinary differential equation with second order with constant coefficient. So what is the general form of is A naught d square y by dx square plus A1 dy by dx plus A2y equal to f of x. This is a general form. So here, in case if we take that the differential operator as d is d by dx, then the equation will becomes a naught d square y plus, as yesterday already we started, few students were absent for the last class, that's why 10 to 15 minutes we recap that how to find that complementary function in particular integral from the yesterday class. A naught d square y plus a1 dy plus a2y equal to f of x. So in case we are taking y outside, then will be that a naught d square plus a1d plus a2 y equal to f of x. So this is a general form. The symbolic we can write this as f of d y equal to f of x. This f of d y equal to f of x has two solutions. The solution called the complete integral. Complete solution or complete integral contains two parts. Just wait. It is asking only 31% present. Okay. Complete solution or complete integral contain two parts. One is complementary function, See, already I sent that video material to find that the complementary function and particular integral. One is complementary function, second one is particular integral. Generally, the complete solution or complete integral can be written as Ci equal to, the complementary function can be written as simply Cf plus particular integral can be written as Pi. So how to find that complementary function and particular integral for the differential equation? Just you listen now. That's in case we started that problem, then afterwards you can write the problem. Just you listen first. How to find the complementary function and particular integral. The solution based on that, the solution based on left hand side of differential equation. Differential equation f of d y equal to f of x is complementary function. See, the solution based on right hand side of the differential equation this f of d y equal to f of x is particular integral. Okay, so that solution based on the left hand side of the differential equation f of d equal to y equal to f of x is complementary function. The right hand side is not required, but the solution based on the right hand side of the differential equation is a particular integral. To find the particular integral, both the left hand side and the right hand side should be required. Okay, so how to find that complementary function? One small recap to find the complementary function. Write the heading to find complementary function. To find the complementary function, first you take that what is the given equation in the format a0 d square plus a1d plus a2 into y equal to some function of x. Is it not? First step is to find the complementary function, make that right hand side equal to 0. As I told that to find the solution of the left hand side, the right hand side is not required. So to make that right hand side equal to 0, then the equation becomes, the differential equation becomes a0 d square plus a1d plus a2 into y equal to 0. The next step is substituting d equal to m in the above equation. If you substituting d equal to m in the above equation, the equation becomes a0 m square plus a1 m plus a2 into y equal to 0, but no need to write that y here, just we write that a0 m square plus a1 m plus a2 equal to 0, which is the second order equation in m. So second degree equation in M, if you solving, what is the name of the equation? This equation is known as the auxiliary equation. The equation is known as that auxiliary equation. Solving that auxiliary equation, simply write AE. Solving the auxiliary equation, we get, so it is a second order equation, is it not? So it is a second degree equation. If you solving the second degree equation or quadratic equation, we will get that two roots. Two roots. The two roots, namely M1 and M2 are two roots. To writing the complementary function, there are three cases are there. One is so based on two roots, we can write the two cases. The case one is the roots are real and unequal. Real and unequal. That means what are the roots here? M1 and M2. M1 is not equal to M2. When the roots are real and unequal, M1 is not equal to M2, then the complementary function can be written as, then the complementary function equal to y equal to C1 e power M1x plus C2 e power M2x. This is the first case. Second case is there, case 2. The case 2 is the roots are real and equal. The roots are real and equal. Just wait. கிளாஸ் எடுத்துகிட்டு இருக்கு, சொல்லுங்கள். The roots are real and equal. In case M1 equal to M2 equal to M. In case the roots are real and equal, then the complementary function y equal to C1 plus C2x e power mx. So the given equation is a0 d square plus a1d plus a2 y equal to 0. In case the right hand side equal to 0, no need to find that the particular integral, only complementary function is enough. To solve that, to find the complementary function, we have to substitute d equal to m in the above equation. We will get one equation. The equation is a quadratic equation. It is called the auxiliary equation. If we solving the auxiliary equation, we get two roots. The two roots are m1 and m2. Based on that nature of the roots, we can write the complementary function. What is case 1? Case 1 is that roots are real and unequal. m1 is not equal to m2. That means the complementary function is y equal to c1 e power m1x, c2 e power m2x. Case 2 is the roots are real and equal. m1 equal to m2 equal to m. At the time the complementary function is y equal to c1 plus c2x e power mx. Then one more case is there. The roots are complex. Case 3. Case 3. In case the roots are complex. That means it contains both a real and a imaginary. So at the time m equal to alpha plus or minus I beta format. Then the complementary function where alpha is the real part, beta is the imaginary part. Then the complementary function y equal to e power alpha x c1 cos beta x plus c2 sin beta x. So there are three cases are there to find the complementary function. For example, if the given equation is d square y by dx square plus 6 dy by dx plus 5y equal to e power 2x. Find the complementary function. The question is find the complementary function CF. At the time, how can you write the solution for this? Make it that right hand side equal to 0. The equation, and then substituting d equal to d by dx, then d square equal to d square by dx square. Therefore, the equation becomes d square plus 6d plus 5, taking that y common outside, y equal to, you are making the right hand side equal to 0 na. To find the complementary function, compulsory you make it that right hand side equal to 0. Next, you have to write the auxiliary equation, substituting d equal to m. Then the auxiliary equation is, what is the auxiliary equation here? M square plus 6m plus 5. When you are writing the auxiliary equation, no need to write that y, okay, equal to 0. After finding the auxiliary equation, you find the root of this. So what are the values of m here? What are the values of m here? Multiplication is plus 5, when you are adding these two numbers, we will get plus 6. What are the two numbers? Multiplication is 5 na? 5 and 1 are the two numbers. Okay, so m plus 5 m plus 1 equal to 0. Is it correct or wrong? Check it then. So m equal to minus 5 comma minus 1. So here the roots are real and unequal. Am I audible? Am I audible or not?
Yes, sir.
Okay. Then the complementary function y equal to, when the roots are real and unequal, then how can we write that? Y equal to c1 e power minus 5x plus c2 e power minus x. So when I am asking that for your response, at least one of them be response, then only I can verify that. In case any wrong is there in the answer, then we have to correct it. Na? So this is the complementary function. In case if it is equal, we have to write differently. In case if it is a complex number, we have to write the different complementary function. And then to find the particular integral, these things is we have discussed on yesterday class. First one is how to find that complementary function. What is the general form? What is the complete solution? Complete solution contains two parts. One is complementary function, second one is particular integral. To find the complementary function, to make it the right hand side equal to 0, and then you have to form the auxiliary equation. Then find the roots of the auxiliary equation. We get two roots. The roots are real and unequal. The roots are real and equal. The roots are complex. So based on the three cases, we can write the solution y. In case right hand side equal to 0 directly, at the time you can write that, no need to write that even complementary. After writing that complementary function, there is no other solution. Na? So that's why you can write that y equal to c1 e power minus 5x, c2 y e power minus x, like that. Next one is particular integral. To find particular integral, to find particular integral. How many cases I told on yesterday? Totally. The right hand side f of x may be that the particular integral is based on the right hand side. Finding the particular integral is fully based on right hand side of the differential equation f of d y equal to f of x. So what is the right hand side here? Right hand side is f of x. The right hand side is f of x. The f of x may be that exponential. It is the case 1. Sorry, it is the type 1. Type 1. F of x may be that algebraic trigonometric it is type 2. Or this f of x may be that algebraic it is type 3. Type 3. Or f of x may be that the combination of this exponential and trigonometric, exponential into trigonometric, or exponential into algebraic, exponential into algebraic, or this f of x may be that it is type 4 now. It is type 4. Or this f of x may be that trigonometric and algebraic, trigonometric into algebraic. This is type 5. There are totally 5 types of right hand side is there. Yesterday we discussed two right hand side. There are two types. One is exponential, one more is trigonometric. See, for example, the exponential type 1. Type 1 is the right hand side f of x may be that exponential. It is in the format of exponential, means it is in the format of e power ax format. E power ax format. Then the particular integral equal to the general format is right hand side by left hand side. So what is the right hand? What is meant by right hand side of right hand side by left hand side means f of d y equal to f of x is the given differential equation. Here the right hand side is f of x, left hand side is f of d. F of d into y is the left hand side, but no need to write that y here. F of x by f of d. Then what is the procedure to solve this? What is f of x here? E power ax by f of d. How to solve this? Yesterday we explained inside the class. Anyone? Anyone, can you tell me that? No one is available. At least one of them can respond my question. How did we solve this? No, it's 1034.
Sir, in denominator we have to substitute d by a.
No, substituting d equal to a in the denominator. If you are substituting d equal to a in the denominator, then the particular integral becomes e power ax by f of a, where f of a should not equal to 0. That means the denominator should not equal to 0. If denominator equal to 0, then multiply with x in the numerator, differentiate with respect to d in the denominator. Just wait. சரி சரிங்க ஓகே சரிங்க ஓகே multiply with x in the numerator and differentiate with respect to d in the denominator. Differentiate with respect to d in the denominator. That is, repeat the same step. Repeat the step until denominator should not equal to 0. So in case that if after you substituting that multiply with x in the numerator and then differentiate with respect to d in the denominator, once again you substitute d equal to a in the denominator. In case if denominator is not equal to 0 is okay, but in case denominator is 0, once again you have to multiply with x in the numerator and differentiate with respect to d in the denominator. Okay, so based on the exponential, we will solve only one problem. Solve the equation d square plus 6d plus 5 y equal to e power 2x is the problem. Write the solution for this. In the solution, the complete integral should contain the two parts. One is complementary function plus particular integral. First you have to find that complementary function, then you have to find the particular integral. So to find the complementary function, make it that right hand side equal to 0, and then we are doing that. Already we have done the same problem here, d square plus 6d plus 5. Here I have done that. Here this is the problem, d square plus 6d plus 5 into y equal to 0. The answer is, complementary function is c1 e power minus 5x plus c2 e power minus x. So here we are writing that the complementary function y equal to c1 e power minus 5x plus c2 e power minus x. Then how to find the particular integral? To find the particular integral, as I told that the particular integral equal to particular integral equal to the left hand side by right hand side by left hand side. Right hand side is e power 2x, the left hand side is f of d is d square plus 6d plus 5. Okay. Even those who are attended the class on yesterday, please write the notes, because these problems are the new problems. So here, yesterday I didn't solve this problem. Substituting d equal to 2 in the denominator. If you are substituting d equal to 2, how to take the d equal to 2 here? That means you have to substitute d equal to a. What is the meaning of d equal to a here is, a is that the coefficient of x in the exponential, is the coefficient of x in the exponential. Then what is the coefficient of x in the exponential? It is 2. So substituting d equal to 2 in the denominator, we will substitute that particular integral equal to e power 2x divided by, if you substituting 2 means d equal to 2, 2 square is 4, plus if you substituting d equal to 2 here, 12 plus 5. So that is e power 2x divided by 12 plus 9, 21. This is the particular integral. Then finally you can write that the complete integral equal to complementary function plus particular integral. The complementary function is c1, I am writing that down, so here equal to c1 e power minus 5x plus c2 e power minus x plus e power 2x by 21. Okay. Now we can add the page, one page here. See, many of them are done the mistake is in the point, they are not writing that complete integral in the final, just they are finding the complementary function, just they are finding that particular integral, then they left that problem as it is. But at final of the problem, compulsory you have to write that the complete integral, which is adding of that complementary function and the particular integral. See, few things you have to be noted here. In case in the given problem right hand side equal to 0, no need to find the particular integral. If some right hand side is given, always right hand side is that function of x, it should not be the function of y. Okay, the right hand side is that function of x. Based on the function of x, you have to find the particular integral. Then we go for the second type, type 2. Type 2 is in case the right hand side equal to f of x, that is equal to trigonometric. So what is the trigonometric here? In case f of x equal to sin ax or cos ax. At the time you have to substitute sin ax or cos ax. Then the particular integral is what? Right hand side by left hand side. What is right hand side here? F of x, that means sin ax or cos ax divided by left hand side. Left hand side is, we know that a naught t square plus A1D plus A2. So in the previous type you are substituting the exponential, you are substituting D equal to A in the denominator. Here we have to substitute D square equal to minus A square in the denominator. No need to substitute anything for D. Substituting D square equal to minus A square in the denominator. After substituting D square equal to minus A square in the denominator provided denominator should not equal to 0. In case denominator is 0, after substituting D square equal to minus A square in the denominator, in case denominator equal to 0, already we have done one step. Multiply with x in the numerator, multiply with x in the numerator, differentiate with respect to D in the denominator. Differentiate with respect to D in the denominator. Repeat the same step until denominator is not equal to 0. So based on this we can solve one problem, one simple problem. In case D square plus 16y, we can solve one problem. Solve D square plus 16y equal to e power minus 3x plus cos 4x. Have we done the problem on yesterday? The same problem. Have we done the problem? Let's check it then.
No, sir.
No? Okay, fine. So now we can solve that. Write the solution for this. Solution equal to, write the solution, complete integral equal to complementary function plus particular integral. In the particular integral there are two right hand side is there, one is exponential, one more is trigonometric, therefore we can write the particular integral as particular integral 1 plus particular integral 2. We have to find two particular integrals. First we have to find that the complementary function. To find the complementary function. To find the complementary function, to make it that right hand, first we make it that right hand side equal to 0. Make it the right hand side equal to 0. Yes, if you make it the right hand side equal to 0, the equation becomes d square plus 16 into y equal to 0. Then you substitute that d equal to m. Substitute d equal to m. If you are substituting d equal to m, the auxiliary equation is every time no need to write that auxiliary equation, just you can write AE. AE is auxiliary equation. So after substituting that d equal to m, the auxiliary equation becomes m square plus 16 equal to 0. Solving this, solving the auxiliary equation, we get m square equal to minus 16. So that implies m square equal to 16 into I. Minus can be written as I square. So m equal to plus or minus 4I. So the roots are complex. The roots are complex. It contains that imaginary complex. Therefore, that m is in the format of alpha plus or minus I beta format. Alpha plus or minus I beta format, where alpha equal to 0 and beta equal to 4. So what is a complementary function here? Complementary function is, if it is the complex e power alpha x, c1 cos beta x, c2 sin beta x. Substituting alpha and beta here, then the complementary function will become e power alpha x. Alpha is 0, e power 0 is 1. E power 0 is 1. Here we can write that complementary function is c1 cos 4x plus c2 sin 4x. After finding the complementary function, we have to find the particular integral. To find particular integral, we know that there are two particular integrals are there. One is particular integral 1 and particular integral 2. What about the particular integral 1? Particular integral 1 is exponential, particular integral 2 is trigonometric. Based on the exponential, we can do that first. Particular integral 1. To find particular integral 1. So in the particular integral, what is the right hand side? Right hand side is e power minus 3x. Left hand side is d square plus 16. So if it is an exponential, you have to substitute d equal to minus 3 denominator. Then the particular integral 1 becomes e power minus 3x by d equal to minus 3 na, minus 3 whole square plus 16. So e power minus 3x divided by 9 plus 16, that is equal to e power minus 3x divided by 25. Okay, it is particular integral 1. Particular integral 2. Particular integral 2 is the left hand side, right hand side is cos 4x, left hand side is d square plus 16. What we need to substitute in the denominator? We need to substitute in the denominator for trigonometric d square equal to minus a square. So it is in the format of cos ax format where a equal to 4. So you have to substitute d square equal to minus a square where a equal to 4, where a equal to 4. Then you have to substitute d square equal to minus 4 whole square. That means minus 16. If you are substituting that minus 16 in the denominator, minus 16 plus 16, then the denominator equal to 0. If the denominator is 0, then you have to multiply with x in the numerator. Multiple with the x in numerator. Differentiate with respect to d in the denominator. Then what happened? Multiple with x in the numerator. It is not only the multiple, it is known as pre-multiple. Pre-multiple means multiple before that value, that means x. Pre-multiple by x here. Write that cos 4x and then differentiate with respect to d in the denominator. If you differentiate with respect to d in the denominator, already d square plus 16 is there. So what is differentiation of, how can we write this? Not like that. D by, differentiate with respect to d na. So d by dd of d square plus 16. D square plus 16. So we will get that 2d. 16 is constant. So here e power 4x by 2d. That becomes x by 2 cos 4x by d. See, d means differentiate with respect to x. 1 by d means integrate with respect to x. D means differentiate with respect to x. 1 by d means integrate with respect to x. So here 1 by d is there. This equation can be written as x by 2. 1 by d can be written as integration cos 4x dx. That is integrate with respect to x, is it not? So, and then in the integration should not include this x. Should not include this x. That is, you are integrating only cos 4x. Because you are pre-multiply that x is not connected with this d. Okay, so x by 2 integrates cos 4x dx. If you are integrate cos, you know that integration of cos x, it is sin x. So x by 2 sin 4x by 4. That means you will get that x sin 4x by 8. It is the particular integral 2. Finally, we have to write that the complete integral equal to complementary function, as I written that particular integral 1 plus particular integral 2. Okay, so the complementary function is C1 cos 4x plus C2 sin 4x plus particular integral 1 is, what is the particular integral 1? Anybody note it down? E power minus?
E power 3x upon 25.
Okay, e power minus 3x by 25 plus particular integral 2 here I have written. That means plus cos x sin 4x by 8. Okay. It is the complete. This is the type 2. So type 1 and type 2, based on that type 1, type 2, some problems may be asked. See, sometimes the same problem may be asking like that. Okay, sometimes the exponential problem may be asking sin hx or cos hx formula. Since I want to write some few formulas here, even yesterday I have written the formula cos hax formula. Cos hax formula. Cos hax is e power ax plus e power minus ax by 2. Sin hax formula e power ax minus e power minus ax by 2. And then based on the trigonometry, yesterday I given one problem. Sin, I think cos square x. Right hand side is cos square x. At the time you have to use the double angle formula. Sometimes cos cube x also will be given. You have to know the triple angle formula. So you should know all the trigonometric formula to solve the differential equation problems. Now we can go for the type 3. So type 1 is exponential, type 2 is trigonometry, type 3. Type 3 is that algebraic. Type 3 is algebraic. If the right hand side f of x is algebraic in the format of x power n format, x power n format, then the particular integral is, everyone has to write this step. I will write step by step. Type 3 is algebraic, it is in the format of x power n format. Then what is a particular integral? The particular integral is right hand side by left hand side. What is the right hand side? Right hand side is x power n, left hand side is f of, I am writing capital F now, f of d. F of d. This f of d can be written as in the format of 1 plus d or 1 minus d format. 1 plus d, 1 minus d format. How can we write that 1 plus d, 1 minus d format of f of d? Just I will explain one step here. In case, in the last problem I written one problem, d square plus 16 into y. In the last problem, just I can go for that, the page. I am not able to go to the page. Anyway, I am writing once again. D square plus 16 is there. In case if it is 1 by d square plus 16. In case if I take that 16 outside, then what happened is, we can write this as 1 plus d square by 16. In case if I take that constant outside, this can be written as 1 plus d square by 16 format. So now we can see that it is in the format of 1 plus d, 1 minus d format. Then we have to write this as 1 by 16, 1 plus d square by 16 whole power minus 1. So this is the thing we are going to do in the step. X power n is there. This f of d can be written as f of d power minus 1 into x power. This f of d is there now. This f of d in the format of either 1 plus some g of t or 1 minus g of t format. So f of d power minus 1 can be written as 1 plus g of t power minus 1 or 1 minus g of t power minus 1. You know the binomial expansion formula. I don't know how many of them are knowing that formula. 1 plus x power minus 1. Anybody? 1 minus x power minus 1. Only two formulas. What is 1 plus x power minus 1? And 1 minus x power minus 1? This expansion is called that binomial expansion. At least anyone try to tell the answer for this 1 plus x power minus 1, 1 minus x power minus 1 binomial expansion. No one is knowing that. At least two steps we can, that is at least two type we can do that today. Feel free. At least one of them can try this 1 plus x power minus 1, 1 minus x power minus 1. One minus x, why you are hesitating to tell the answer, I don't know. 1 minus x plus x square minus x cube plus etc. alternately plus minus 1 minus x power minus 1 is 1 plus x plus x square plus x cube plus etc. This is the formula. Then we can expand this by using binomial expansion. This f of d power minus 1 x power n can be expanded by using binomial by using binomial expansion then find the particular integral. Okay, so simple example can give here. So first we have to write that x power n by f of d format, then take to the numerator f of d power minus 1 x power n. Then we can expand that f of d power minus 1 by using the binomial expansion, then find the particular integral. See, for example, example 1, solve d square plus 3d plus 2 into y equal to x square. This is the problem. Solve d square plus 3d plus 2 into y equal to x square. First you start to find the complementary function. Already you know how to find the complementary function for this. Complete integral equal to complementary function plus particular integral. So what is the complementary function for this? Anyone? Complete integral equal to complementary function plus particular integral. I will find the particular integral. Just what is the complementary function here? Make it the right hand side equal to 0.
C1 into e power minus 2x plus C2 into e power minus x.
Complementary function is C1 e power minus 2x plus C2 e power minus x. Okay. Then we are going to find the particular integral. It is very important. How to take the value outside in the denominator. Now just listen. X square divided by d square plus 3d plus 2. Very simple. Take constant outside. Whatever the constant is there, take outside. Take constant outside in the denominator. Outside in the denominator. So what is the constant here? 2 is the constant. X square divided by whatever the constant is there, take outside. 2 divided by 1 plus d square plus 3d by 2. Very simple. Last term is there, na constant term, take outside. Then it will become in the format of 1 plus d or 1 minus d format. It is a simple concept. Take the constant term outside. X square by 2 into 1 plus. So this equation will become, keep it that 1 by 2 and take it to the numerator. 1 plus, denominator take it to the numerator, 1 plus d square plus 3d by 2, put the bracket here, close the bracket, power minus 1 into remaining thing is the x square. Don't write the x square here. Don't write that x square by 2. Okay. You write that the d terms first, then you write that x square next. Now, after writing that x square, as I told that you have to take in the format of 1 plus x power minus 1 format. So the whole thing taken as some x. Okay. Or already here x is there, so you will get confused. Otherwise we can write it as 1 plus a power minus 1 format. So to take all the things is 1 plus a power minus 1, that is equal to, already expanded na, 1 minus a, alternately plus or minus, plus a square minus a cube plus etc. Okay. Now up to which term you have to be expanded? Up to which term you have to extend? Based on this x power, x square is there na, up to second term you have to be expanded. That is, you have to find 1 minus a plus a square. That a cube a power 4 no need. If only x is there, you expand up to only 1 power. X square is there, expand this up to 2 powers. So the particular integral can be written as 1 by 2 1 minus d square plus 3d by 2. 1 term, then next term is plus d square plus 3d by 2 whole square minus etc. Okay, so that remaining things no need. Now x square is there. As I told that what is d? D means differentiation with respect to x, is it not? So what is mean by d of x square? D of x square means dy dx of x square. At least one of them can join with me, then only it will be somewhat interactable class. So d of dx by x square is 2x, is it not? So what is mean by d square? D square of x square. D square of x square means what is mean by d square of x square?
Double
D
time.
square by dx square 2 times differentiation of x square. So once again you have to differentiate the 2x is 2. What is mean by d cube? D cube means d cube by dx cube of x square. See, already it is 2, then if you are differentiation 2, you will get 0. That's why even if you are expanding this term to third one, it will be 0 only. Third one, fourth one, fifth one, all are 0. So up to that second term you can expand. The third term, the third power, fourth power will be automatically will be 0. Okay. So d power 4 of x square, etc. all are equal to, the other things are equal to 0. Okay. So multiply that x square inside that bracket. 1 by 2 is there. Now the particular integral becomes, what happened? 1 by 2, keep it that. What is the first term? Multiply with x square inside. So 1 into x square minus d square plus 3d by 2 x square plus, next one is d square plus 3d whole square is there, na? Divided by 2 is there. Divided by 2 can be written as, that is also square. So 1 by 4. Expand this, d square plus 3d whole square, d power 4 plus 6d cube. If anything wrong is there, please tell me that. Plus 9d square into x square minus the other things are 0. Leave it. So you are multiplying that x square inside the bracket. Now the particular integral is 1 by 2 x square minus d square x square by 2, plus and minus is minus 3 by 2 d of x square plus 1 by 4, only x square, d square we can take. Okay, it is not d square actually, d square whole square, na? It is d power 4, na? No one is mentioned. 1 by 4, the d power 4 will be 0, d cube will be 0, only d square will be there. So 9 by 4 d square of x square. The other things are 0. Leave it. Now 1 by 2 x square, keep it that. What is d square x square? D square x square is 2 here. Here I mentioned. So d square x square is 2 minus 2 by 2 minus 1. And then minus 3 by 2 is there. Sorry, 3 by 2. D of x square. D of x square is what? D of x square is 2x. So minus 3 by 2, 2x. Three by 2, 2x plus 9 by 4. D square x square is 2 into 2. So that get cancelled. 9 by 2 will come. And then minus 1 plus 9 by 2 is. So how can we simplify this? 1 by 2 x square minus 2 to get cancelled, minus 3x, then minus 2 plus 9, minus 2 plus 9 plus 7 by 2. Is it not? Is it correct? Okay, so this is the way to find that the particular integral. In case if it is x square, the algebraic is given. First you take the constant outside in the denominator. When you take the constant in the outside in the denominator, 1 plus d square plus 3d by 2 will come. Then expand by using the formula, binomial expansion formula. That is, we have to be expand up to power 2. That x square, based on this x square, we have to expand up to power 2. The x cube, x power 4 will be, that is d power d cube, d power 4 will not come. Therefore, after simplifying this, you are getting that particular integral. Then what is the complete integral now? Finally, write the complete integral equal to complementary function plus particular integral. What is the complementary function? C1 e power minus 2x plus C2 e power minus x plus 1 by 2 x square minus 3x plus 7 by 2. Okay. So this is one problem. Okay, one more problem. D square we solve that one more problem based on this. Solve d square plus d into y equal to x square plus 2x plus 4. It is also the algebraic equation. At the time, how can we solve this? Here we can look into that there is no constant term in that equation. At the time, what can we do? In case constant term is there, we can take the constant term. In case constant term is not there, at the time, simply you take that the lower power of d outside. Take the lower power of d outside. First we have to find that complementary function. Complete integral equal to complementary function plus particular integral. No need to write that particular integral 1, particular integral 2. Fully we can, fully it is that algebraic equation, so we can take that is a particular integral. How to find the complementary function? First we have to find the complementary function. What is the complementary function here? Make it that right hand side equal to 0, substituting d equal to m. You will get that the auxiliary equation is m square plus m equal to 0. So taking that m outside, m plus 1 equal to 0, that is either m equal to 0 comma minus 1. Therefore the roots are real and unequal. The roots are real and unequal. Then the complementary function is, and the complementary function equal to c1 e power 0 into x plus c2 e power minus x. So that means c1 plus c2 e power minus x is a complementary function. To find the particular integral, to find the particular integral, the particular integral equal to left hand side by right hand side, right hand side by left hand side. The right hand side is x square plus 2x plus 4 divided by d square plus d. So here you take the d outside. X square plus 2x plus 4, the denominator, take d outside. We can write that as d plus 4. So we can write that as 1 by d. 1 by d, the d plus 1 taken to the numerator. That can be written as 1 plus d power minus 1 x square plus 2x plus 4. What is the higher power here of x? What is the highest power of x? Highest power of x is 2. So based on this, we have to expand this 1 plus d power minus 1. One plus d power minus 1. So 1 by d how can we expand that 1 plus d power minus 1? 1 minus d plus d square minus d cube, etc. So x square plus 2x plus 4 multiply. That is equal to 1 by d. Multiply that x square plus 2x plus 4 inside, we will get that x square plus 2x plus 4 close the bracket minus d into x square plus 2x plus 4 and then plus d square into x square plus 2x plus 4. The remaining things are 0. Leave it. So 1 by d x square plus 2x plus 4 minus what is d of x square plus 2x plus 4? What is d of x square plus 2x plus 4?
2x plus 2, sir.
2x plus 2. And then one more term is there, plus d square is there. D square of x square plus 2x plus 4 is
2, sir.
2. Okay. Now you have to be simplify the term x square plus 2x minus 2x get cancelled, and then if you simplify that, what you get? Minus 2 plus 2 get cancelled. The 2x plus 2x minus 2x get cancelled. Minus 2 plus 2 get cancelled. Only remaining things are x square plus 4. As I told that 1 by d means integration. Integration of x square plus 4 with respect to x. Yes. So you will get that x cube by 3 plus 4x. Therefore, the complete integral equal to complementary function plus particular integral, complementary function plus particular integral. Complementary function is c1 plus c2 e power minus x plus x cubed by 3 plus 4x. This is the complete of the thing. So there are three types we are discussing. First one is exponential. In case if it is exponential, you have to substitute d equal to a in the denominator. If it is a trigonometric, type 2 is trigonometric. In the trigonometric, you have to substitute d square equal to minus a square in the denominator. No need to substitute anything for d. You can write as a note also. And then third type is algebraic. If the type is algebraic, then you have to take the denominator to the numerator and expand by using that binomial expansion. Then you can multiply that the algebraic time inside that the expansion, and then we can find the answer for this. Okay. Type 4. Type 4 is if that right hand side f of x equal to any function multiple with exponential. That means it may be in the format of e power ax into trigonometric or e power ax into algebraic. Then how can we solve it? At the time, the particular integral becomes e power ax. The trigonometric algebraic I am written as some g of x. The g of x may be the trigonometric or g of x may be the algebraic, I don't know. divided by g of x divided by, what is the left hand side? Left hand side is f of t. At the time you have to write this step as taken that e power ax outside, write separately e power ax, write that e power ax separately, then g of x, write that in the denominator d tends to d plus a. That a is there na, that a is that coefficient of x in the exponential, coefficient of x in the exponential, where this a is that coefficient of x in the exponential. Now that g of x is the trigonometric and algebraic, as usual we know how to solve that if the function is the trigonometric algebraic. That is exponential, now no need to that is not in the consideration. That is, you have to be separate from the denominator, just you applying that d tends to d plus a. Then afterwards we can solve that the equation. This process is called that exponential shift. This process is called the exponential shift. Exponential shift is one important M.Sc. So in case, for example, the given problem is in the format of d square minus 2d, simple problem I can solve d square minus 2d plus 2 into y equal to e power minus x into x square, e power minus x into x square. So here the particular integral, see that it is in that format of e power ax into g of x format. Here the g of x is algebraic. So how can we solve it? First we have to find the complementary function. To find the complementary function, make it that right hand side equal to 0 and substituting d equal to m. So first you have to write that complementary function heading na. Complementary function, make it that right hand side equal to 0 and substituting d equal to m. Then the auxiliary equation is m square minus 2m plus 2 equal to 0. So here we have to use the formula minus b plus or minus root of b square minus 4ac by 2a formula here. So substituting that value, minus b is 2 plus or minus square root of 4 minus 8 by 2. So we get that m equal to 1 plus or minus I. 1 plus or minus I. It is the format of alpha plus I beta format. So here alpha equal to 1, beta equal to 1. Okay. Therefore, the complementary function is equal to e power x c1 cos x plus c2 sin x. That is a complementary function. Then come to the particular integral. The particular integral equal to 1 by d square minus 2d plus 2 e power x into x square. That is equal to, do the exponential shift here. That means shifting the exponential to front, e power x, and then now you have to be substitute. It is known as exponentially shift. Not exponentially, exponential shift. So you are shifting that exponential. In the exponential of shift, what we are doing? D tends to d plus a. So what is a here? A is 1. So therefore you have to substitute d tends to d plus 1 in the denominator. If you are substituting d tends to d plus 1 in the denominator, you will get that d plus 1 whole square minus 2 d plus 1 plus 2 x square. That is equal to e power x 1 divided by d plus 1 whole square is d square plus 1 plus 2d minus 2d minus 2 plus 2. So plus 2d minus 2d get cancel, minus 2 plus 2 get cancel. We will get only that d square plus 1. So e power x into 1 by d square plus 1 into x square. What is the next step? Next step is you have to, it is algebraic, na? X square is algebraic. So you have to write this as e power x d square plus 1 whole power minus 1 x square. So it is in the format of 1 plus d square format. Instead of writing the d square plus 1, you can write as d square plus 1. Sorry, 1 plus d square format. If you are expanding that, you will get that 1 minus d square plus d power 4 minus d power 6, etc. But already we know that power of x is only 2, so the d power 4 not required. Therefore, e power x, multiply that x square inside, x square, and then d square of x square is 2. So x square minus 2 is the particular integral. X square minus 2 is the particular integral. Then finally we can write the complete integral. Complete integral equal to complementary function plus particular integral. Complementary function is e power x c1 cos x plus c2 sin x. Particular integral is e power x into x square minus 2. Okay, fine. It is exponential into algebraic. In case if it is exponential into trigonometric, How can we solve that? Example number 2. D square plus 4D D square plus 4D plus 4 y equal to e power minus 2x into sin x. D square plus 4D plus 4 into y equal to e power minus 2x into sin x. So how can we solve this? Write the solution for this. Find the complementary function. To find the complementary function, make it that right hand side equal to 0. Make right hand side equal to 0 and substituting d equal to m. Then the auxiliary equation is m square plus 4m plus 4 equal to 0. So m equal to minus 2 comma minus 2. The roots are real and repeated and equal. Therefore the complementary function is c1 plus c2x into e power minus 2x. To find the particular integral equal to e power minus 2x sin x divided by the d square plus 4d plus 4 can be written as d plus 2 whole square. Based on that exponential shift, we are writing that e power minus 2x shifting that exponential, then 1 by substituting d tends to what need to substitute? D tends to anyone?
D plus 1.
D minus 2.
D tends to d minus 2 because the exponential, it is in the format of e power ax format. So here a is minus 2, we have to write the d tends to d minus 2. If we are writing d tends to d minus 2 here, d minus 2 plus 2 whole square and then sin x we have to write. So that is e power minus 2x minus 2 plus 2 get cancelled, 1 by d square. See, 1 by d square means 1 by d mean integrate with respect to x one time. 1 by d square means integrate with respect to x two times. So this can be, otherwise we can write this as e power minus 2x 1 by d and then write 1 by d. That 1 by d sin x. Write like that. Then in the next step we can write that e power minus 2x 1 by d. That 1 by d becomes that integration over sin x. The integration over sin x can be written as e power minus 2x into 1 by d minus cos x. Minus cos x. Once again you have to integrate this, but when you are integrating that, don't take account that e power minus 2x exponentially already you shifted in front, so it is no way connected with that. Therefore e power minus 2x, take it minus outside, Once again 1 by d is there, that 1 by d we can write as integration cos x. Integration of cos x is sin x minus of e power minus 2x sin x. It is a particular integral. But this problem is somewhat easy because the denominator is only d is there. In case some other value is there, d square plus or d square minus is there, you know already how to solve the trigonometric problem. So finally we can write the complete integral. Complete integral equal to complementary function plus particular integral. Complementary function is c1 plus c2 x e power minus 2x, and the particular integral is minus e power minus 2x sin x. Either you can take that e power minus 2x common and then you can write, it's not the problem, but even you can end up to this problem, up to this step, but compulsory you have to write that this complete integral. Okay, so up to now we have discussed 4 or 5 types, 4 types. That is, type 1 is exponential, type 2 is trigonometric, type 3 is algebraic, type 4 is the function multiply with exponential. So one more type is there, the function which contains that algebraic and the trigonometric. Then how to solve this we can see in the next class. Next we will meet on day after tomorrow. Thank you. You can leave the class now. You can leave the class. Anyway, I will post this video material to you. If those who are not copying this, please copy the notes.